Hey, 7th graders. Today's lesson is 3.6 traits. Your learning targets for today are a little bit of science and a little bit of just our content-specific phenotypes and genotypes of genetics. So I can predict the genotypic and phenotypic ratio of the offspring of two parents. So basically what you're looking at when we talk genotypic and phenotypic ratio is percentages. So if we were to breed two parents, what percentages of genotypes and phenotypes would we see? And we'll definitely dig a little bit more into that in class, as well as we move on to do Punnett squares. I can gather data to test a claim, so you guys will be using the sim for both of these next two, and then I can use evidence to support my claim. So as usual, you're watching this video, great job, but for the record, I usually keep a link to the video on the first page that you guys can right-click and open. Eventually, I'm going to stop putting the video links on today's Teams post and just put them in the assignment. All right, so moving on to the warm-up today. So notice that your guys' indicator that you have something to do on a slide is this yellow question mark for today. So look for that yellow question mark. I can already see a couple if I look over at my slide preview on the left. All right, so for your warm-up, you guys have this diagram for silk flexibility in the spider family. So we have a bunch of Darwin bark spiders, and you guys can see parent 1 is a male, and he has low silk flexibility. His genotype is F1, F3. Parent 2 is a female. Her phenotype is medium silk flexibility, and her genotype is F1, F2. Okay, what we see is we had 4 offspring produced from this mating, and we had a male with low silk flexibility, F1, F1, a female with medium silk flexibility, F1, F2, a male with low silk flexibility, F1, F1, and another female with high silk flexibility. So that's different than both of the parents and all of the other siblings. Okay, so the question that you guys are supposed to answer is, study the diagram on the left. From what you observe in the diagram, do you think the offspring have developed a mutation? So remember, a mutation is a change in DNA. Do you think that they have developed a mutation that causes them to have different phenotypes for silk flexibility? So I think mainly what we're looking at here is this high silk flexibility, where we have a low parent and a medium parent, but they have an offspring that has high. So do you think that offspring D has developed a mutation to give them high? What I want you guys to consider when you answer this question is consider the male with the genotype F1, F3. He has 2 options of alleles he could pass down. He could either pass down F1 or F3. And the mom has medium silk flexibility with the genotype F1 or F2. So she has, again, 2 options of what she can pass down. She can either pass down an F1 or an F2. Okay, so just like in the last lesson, I want you guys to think about all the different combinations that you could produce with the children. Okay, so if dad passed down an F1 and mom passed down an F1, you would have a baby with F1, F1. Okay, so I want you guys to think about that, especially in regard to offspring D. So make sure you answer why or why not. Again, think about what I just explained to you guys. All right, moving on. Activity 2 is your simulation for the day. So I really like this simulation and this activity because you guys have a mission. So let me read your mission for you. It's help Bay Medical Company decide which spiders to breed. So launch the sim and determine which parents researchers should breed in order to produce offspring with the trait for medium silk flexibility. Record your results in the tables below. Then share your recommendation with Bay Medical Company. Note, you may need to run multiple tests with the same or different parents. So we're going to do that, and I'm going to do the first example for you guys. So you guys are going to run 3 tests, and like I said, we're going to run the first one together. So you guys will have that information for you. But basically, a lot of medical companies will use organisms, other living organisms, in this case it would be spiders, to produce something that they need for the human body. So for instance, pigs have a really similar anatomy to the human body. And so we actually use pig valves from their hearts for a lot of replacements in our hearts. That is until we kind of got a little bit better at building technology that we could use in hearts. But pigs are really similar to humans, and so we can use their organs in place of ours sometimes. So just the same, if we look at spider silk, if any of you guys have ever heard of anyone who's torn their maybe ACL or MCL, sometimes you need to replace those tendons, and you need something that's really, really strong but a little bit flexible. So in this case, you could possibly use spider silk. Okay, so low spider silk may be a little bit too flexible or a little bit too rigid, And high spider silk might be a little bit too flexible. So what these researchers are looking for is 2 spiders that will produce the most amount of offspring that can produce medium silk, because the more spiders they have in their lab producing medium silk, the more they can experiment with potentially being able to repair different things in our body using spider silk. It sounds kind of crazy, but it's totally could happen in real life. Like I said, often medical researchers mimic or use things that other organisms either produce or create, or something that's in their body, in the human body, because it might work good for us if it works good for them. All right, so you guys will need to right-click the sim link. Remember, if you're using a Chromebook, you right-click by double tapping with 2 fingers, just gently giving like a little snake bite tap, and then click open link. It might reroute you through Clever, but once you guys have signed in through Clever, you guys will go directly to the link. So I've already signed in for Clever, so it should go directly to my sim. All right, so moving on, you have 3 tests, and we're going to do the tests together. So I'm looking at silk flexibility, so I'm going to change my trait to silk flexibility, and I'm going to need to pick 2 parents, a mom and a dad. Okay, I'm going to be looking for spiders that I think if I mate them, they're going to produce a lot of offspring with medium silk flexibility. So I'm going to go ahead and start with maybe 2 mediums. I think maybe, all right, if I cross a medium with a medium, then maybe I will get a lot of offspring that have medium. You guys are going to run this breeding 3 times and see what happens. So let's take a look, and let's try for this one Leo, because he's medium, and Ruby. So phenotype for Leo and Ruby are both medium. Okay, assuming they're both medium, they probably both also have the same genotype. So F1, F2, F1, F2. Great. So I'm going to go ahead and go in here and type in F1, F2. So this just gives me a little information about the parents that I'm using. Okay, now I'm going to go ahead and do their breeding 3 times. I'm going to go ahead and click and drag one spider on top of the other to produce offspring. And I'm going to click Create Reproductive Cells. Those are going to show me their different combinations of their genotypes that they could pass down. So Leo could either pass down an F1 or an F2. And same with Ruby, either an F1 or an F2. So we might see any combination of those F1 and F2s in the offspring. And then I'm going to go ahead, randomly fertilize. And I'm going to take a look at the offspring and kind of get a rough idea of which percentage of them have medium silk flexibility. So I have high, low, high, low. In that case, I had 0. Okay, so I'm going to go ahead and reset my simulation. I'm going to do that again. Leo and Ruby, create reproductive cells, and then randomly fertilize. And again, I'm going to take a look at the offspring. Like I said, you're going to want to do this 3 times so you guys have a good idea. You might have not had any, you might have not had any in the first breeding, but you might have some in the second. So let's look. There we go. We have 1 out of 4 have medium this time. So that's 25%. So on the first one, we got 0%. This one, we got 25%. We're going to kind of just have a tiebreaker with our third one. We're going to reset it. We're going to click back into silk flexibility, drag Leo and Ruby together, create reproductive cells, and then again, randomly fertilize and take a look at the offspring. All right, so we've got medium, medium, and a low and high. So this is why we do it a 3rd time, okay? So in this case, we've got 2 mediums now, so 2 out of 4, which is 50%. So if we kind of average, we had 0 the first time, 25 the second time, and 50. That's about an average of 25%. So that's not a great average. So we're going to go into our draw tool. And I'm going to go ahead and circle 25% roughly, okay? So at the best or on average, we're going to see that every time we get spiders produced from Leo and Ruby, they're only going to give us 25% offspring that can produce medium silk. So as a researcher, that's not a very good percentage. Okay, we want 100% or pretty close to 100% of our spiders producing medium silk. Okay, so with that being said, make sure again, anytime you use the draw tool that you click back on the cursor. You guys are going to run 2 more tests. So we know that Leo and Ruby probably not our 2 best parents. So you guys will want to reset it. Go back to silk flexibility, and then just take a look. What do you guys think? If the genotype for medium is F1, F2, what do you guys think would be the best breeding to do to get the highest percentage of offspring that are producing medium silk? Okay, so you'll run test 2. Again, you'll run it, you'll breed them 3 times. Let me know the information about the parents, and then circle after 3 times about what your percentage is. You don't want to always just do your best percent, because I think if we were to deliver that information to a researcher, they'd be a little disappointed if they weren't getting that every time. Okay, so circle 0, 25, 50, 75, or 100. There's only 4 offspring that are produced each time, so really you're just going to be going by increments of 25%. Okay, and then run it a 3rd time. Again, pick 2 parents that you think might do better. Maybe you guys really nailed it and you got 100% on the first one or on the second test. That's great. Go ahead and just kind of see if there's one that you can get that's equal or better. Maybe there's multiple parents that we can be breeding here to get the best spider silk. Okay, so do that test 3 times, and again, for each test, you're going to breed the parents 3 times as well. So you guys should be running 9 tests for this. Technically only 6 because I ran the first 3 for you. Okay, finally, if you were to deliver your results to the Bay Medical Company, which parent should they use? So parent 1 are the female, parent 2 is the male. What is the best silk flexibility for those parents to have? And then what is the best genotype for those parents to have? And then finally, this is the most important part of that, is you guys are going to explain why you would use these 2 parents. Use evidence to support your answer in the form of data percentages. So somewhere in that answer, you guys should be talking about the data and percentages that you guys got from these 3 tests. If you guys don't include anything about data or percentages, you guys haven't accomplished that learning target for today, but about using evidence to support your reasoning. Okay, so make sure you do that for full credit. And then finally, this is a required slide. You guys do need to do the wrap up. Takes about 2 seconds. Any questions, circle yes or no. If you have a question, type it in. Obviously, if it's preventing you from finishing this assignment, you're going to want to either rewatch this video or hit me up in Teams. And then 4, 3, 2, 1, how do you feel you did? Okay, do you feel confident in your answer that you selected and how you guys conducted your experiments? And then finally, you guys are done. You can check that you're done, turned it in, and enjoy this picture of me riding this robot horse spider. Okay, I hope you're all having a great day, and I will talk to you soon. Bye.